Welcome to the Math Record. Today I'll be covering the ICTM State 2018 Division AA Precalculus, which I'll be answering questions 9, 10, and 13. As usual, scroll down all 20 questions if you want to answer these by yourself, and I'll provide the answers at the end. Okay, let's begin with number 9. A group of 5 men and 5 women are randomly seated at 10 chairs around a circular table. Determine the probability at least 2 men are seated next to each other, or at least 2 men are seated. Two women are seated next to each other. So basically, if you have a circular table and you're seating up 10 people, because 5 men and 5 women, that's 10 people, how many ways can you order them? Well, basically, if it's circular table and we're going around, it stops exactly at the first one again. So basically, we have the total amount minus 1. And that's the idea of that a circular table. So you have 10 minus 1, which is 9 factorial. So there's 9 factorial ways, because there's always going to be a factorial in there, 9 factorial ways to order amount of people. So then, because the first one doesn't matter. So if you kind of think about it, now if we have men and women, because if there's at least 2 men seeing each other or at least 2 women are seeing each other, instead of thinking about that case, let's think about the reverse case, which is if they alternate. Because if they alternate, then basically no men or no women are seeing each other. So the total amount of combinations minus the amount of people that alternate should be the amount of people that at least 2 men are seeing each other or at least 2 women are seeing each other. So basically, think about that negative case. So let's just use the smallest possible. So women, men, woman, men. So let's say men is in the beginning. So that means you have to subtract 1 from the beginning. Same thing as what we did for when it was total, right? Total 10 people. So there's 5 people, 5 women. So how many ways can we arrange 5 women? Well, that's 5 factorial. Remember, we gotta subtract 1. So that's 4 factorial. How many ways can we arrange the 5 men? Well, that's 5 factorial. And remember, since they're not at the beginning at that first point, that means it doesn't matter. So that means they don't have to subtract 1. So that means 4 factorial times 5 factorial is the amount of ways you could order alternating people. So that means 9 factorial minus 4 factorial times 5 factorial is the amount of the amount of combinations that at least two men are seeing next to each other or at least 2 women are seeing next to each other. And then we divide by 9 factorial, the total amount, to get our total probability. So 9 factorial is 1, minus 4 times 3 times 2 times 1, because 5 factorial 9 factorial makes 9 times 8 times 7 times 6. And 4 and 2, that cancel with 8. 3 and 9 makes 3. So 7 times 6 is 42. 42 times 3 is 126. So this will be 1 minus 1 over 126, which is equal to 125 over 126. And that is your probability for number 9, which is also your answer. Okay, question 10. The graph of the polar equation r equals 2 times 1 minus sine of theta on a standard grid is a cardioid. A circle is circumscribed about this cardioid so that the two figures are tangent at the right and left extremes of these cardioid. Determine the exact radius of the circle. So when you're working with polar and you want to look for basic, okay, so first let's just get a picture to see how this looks. It's kind of hard to explain with just words. So we have like some kind of circle, and it's just a general picture. There's no numbers or anything. So our cardioid looks like a heart, or something like that. So this graph, 2 times 1 minus sine theta looks something like this, and it's like a heart. So basically, the right and left extremes would be like somewhere right here, and so right here, and this graph should look symmetrical around right here. So basically, if we're making a circle that goes through these 2 points, and those are the extremes, well, basically that's going to be a diameter. So that basically tells us, since this graph is symmetrical at this axis, at the y-axis, we kind of could find the length of this radius by looking for the x value, which is basically just going to be r times cosine of theta, because this is going to be your r times cosine of theta will give us this length, which is going to be our radius. So it was kind of a really bad picture, but it's generally how polar coordinates work. So r times cosine theta. So what's r? Well, r is given to us. That is 2, 1 minus sine of theta times cosine of theta. So we need to maximize this to get our maximum radius. Let's call that m. So maximum radius is m. So how do we get our maximum radius? Well, basically, to get our maximum radius, if you want to think about theta, there's only ever three angles that work. It's the 30, the 60, or the 45. And that's usually for all contests. And we could just check for each one, so we don't really need to spend all the math to prove why it's the 30, 60, or the 45. So, but we also have to think about this logically, because if sine of theta is negative, 1 minus a negative is equal to a positive. So we could make sine negative and cosine positive. So maximize the m. So that means we're working for a negative sine and a positive cosine, which means we're in the fourth quadrant. So if we're working at the 30 degrees, 30 degrees is right here. That means we're working at 330 degrees because 330 plus 30 is 360 for the entire circle. And if we're working at the 45, right, that'll be 360 minus 45 is 315. And now we're working at the 60, right? That means 360 divided minus the 60 is 300 degrees. So this is the 30 degrees, the 45 degrees, and the 60 degrees. Okay, now let's find the measure for all of them. So the sine of a 30 degrees is going to be 1/2. Since it's negative, it's negative 1/2. The cosine of a 30 degrees is square root 3 over 2. And then the sine of 45 would be negative square root 2 over 2, and the cosine is square root 2 over 2. And then the cosine of the sine of a 60 degrees is going to be square root 3 over 2. Negative is going to be 300, the 30 degrees, 300 degrees. And the cosine of that 300 degrees is going to be 1/2. Right? So just plug in theta to each of them to get all your sines and cosines, and that'll just test which one's the biggest. So all you have to do is just put this in your calculator. So 2 times 1 plus 1/2 times square root 3 over 2. 2 times 1 plus square root 2 over 2 times square root 2 over 2. And 2 times 1 plus square root 3 over 2 times 1/2. So so using your calculator to check all three, and whichever one is the bigger number is your maximum radius. And that's all you have to look for because this is going to be the extreme. So 2 times 3 over 2 times square root 3 over 2, that is going to be equal to, so times square root 3 over 2, that's like 2.598. This one is going to be 2 times 1 plus square root 2 over 2 times square root 2 over 2. Times square root 2 over 2 is equal to 2.414. And this is 2 times 1 plus square root 3 over 2 times 1/2, which is equal to 1.866. So the maximum is obviously this one, so we just need to simplify this to get our exact answer. So 2 cancel with this 2 to get square root 3. And 1 plus 1/2 is 3 over 2, so this is 3 square root 3 over 2. And that is your answer for number 10. Okay, now let's go to number 13. The graph of x to the power 5 plus y to the power 5 equals 1 and x plus y equals k have exactly one intersection in the first quadrant. The exact x-coordinate of this point can be written as p to the power w. Determine the sum of p to the power w. Okay, so this is kind of hard to understand, so let's just kind of rewrite it as y is equal to 1 minus x to the power 5 and then the fifth root of it. And if you kind of graph this in your calculator to see what's happening in the first quadrant, basically it looks something like this, and then some kind of hump, and then goes back. So if we have x plus y equals k, for it to intersect at one place, it's going to intersect right here. And if you kind of look at the graph, something looks really suspicious about it, right? If you draw this line go through the origin right here, and this line, which we could label as the equation y equals x, right? It's symmetrical. So basically, all we have to do is substitute y with our x. So using our first equation, that's x to the power 5. Y to the power 5 is x to the power 5 is equal to 1. That means 2x to the power 5 equals 1. So that means x to the power of 5 equals 1 divided by 2. So then we just need to raise, so that means x is equal to 1 half to the power of 1 fifth. So that will be our x-coordinate. So if we rewrite it using integers, that's 2 to the power of -1, -1 to the power of 1. To the power of 1 over 5 is negative 2 to the power of -1 over 5. So what is our x-coordinate? Well, this is your x-coordinate, right? Because it has to go, because using the picture that I just gave you with some kind of hump, right, in this line, your y is equal to your x. That means this coordinate is x comma y, and your y is equal to x. So basically, your x and y's are both this coordinate. So your x coordinate is just this. So p is equal to 2, and your w is equal to -1 over 5. Add them together, so that's 10 over 5 plus -1 over 5. That's 9 over 5. And that's your answer for number 13. So you don't always have to solve for questions. All we have to do is just look at a picture, see what's happening, and make easy, simplified like solutions. And as promised, here's all 20 questions. Well, thanks for watching, and I'll see you at the next math record.